Okay, so chromatography. Chromatography is just a technique to separate compounds or mixtures of compounds. And we tend to demonstrate that using a very simple technique, using coloured pens, felt tip pens, because they are a mixture of different colours. And we have a chromatography paper, which is usually filter paper, so a little bit coarse. Paper towel at home, kitchen towel, works just as well. And what that does is, if we put this chromatography paper into a beaker of water, the paper draws the water up, and this ink dot here is soluble in the water. If this is made of different coloured inks, then those different coloured inks will have a bit of stickability about them. They'll stick to this paper to different degrees. The ones that don't stick to this paper will go with the water, will be dissolved with the water, and will move up the chromatography plate. But the colours that do stick to the paper and aren't so soluble in the water won't go as far, because they'll stick to the paper. The paper will keep them, oh, I've done that in the wrong place, because the paper will keep them stuck. Okay, so this dot will split into its different colours. Okay, so we've got that idea. So this is a before and this is an after. So once the water has been drawn up the paper, we take the paper out of our beaker, and what we do is we make a water mark. So this is called our solvent front. So basically it tells us how far the solvent has moved compared to our origin line. So this is our origin, where we put our ink in the first place. So this is our origin, and this is the origin line. So how far did the solvent move? And what we do, we want to know, well, what was the fraction of that movement? How far did these move as a fraction of that? Okay, so what we have to do is measure this line here. In an exam, they might actually tell us what that line is. They might say, oh, the solvent moved 10 centimetres, and the different coloured dots moved 1 centimetre, 3 centimetres and 5 centimetres. And all we're doing is trying to find a fraction. So what we have to do is we need to know how far the water's moved in the first place. So we measure, this is where we would have put our cross. So we measure from where we put our ink in the first place, and we measure to the solvent line, and this looks like about 55 millimetres. So that solvent, that water, moved 55 millimetres. So what fraction of 55 millimetres did these spots move? So if I say take the blue spot, I go from the origin line, because that's where the ink was to begin with, and I measure to the centre of that spot, and that looks about 39 millimetres. So that moved 39 millimetres. You can't see that very well. So that's 55 millimetres, and that's 39 millimetres. So what fraction of 55 is 39? So that's what the RF value is, a fraction. So it's how far the spot moved divided by how far the solvent moved. And we tend to write this as 39 over 55. And we can get a decimal number for that. And that's what we're looking for. So the RF value is a decimal number. So 39 divided by 55 is 0.709090. I'm going to just take it to 2 decimal places. So 0.71. So the RF value for that is 0.71. And we can do the same for the others. So we can get values For the pink one looks to be 27 millimeters, and this is a purple one. It looks black, but it's purple, and that's 15 millimeters. So that's 15 millimeters. So I would just find what fraction of 27 millimeters of 55 millimeters is 27. So that would be 27 divided by 55, and this one is 15 divided by 55, and that will give me an RF value for that, a decimal number, and it would give me a decimal number for that. And what's the value of this? Well, if I did this again with my black ink but had a bigger sheet of paper, I could let the solvent move up much further and I would get better separation. But this RF number, this fraction, will always be the same regardless of how big that sheet of paper is. This RF value will work out to be the same. So the value is, you can use these RF values on any size of paper, and you can be certain that the value would represent that colour, or that identified colour, regardless. Okay, but that's why we work out the RF values, so we can, if we have a different piece of paper and the RF value is 0.71, then we know it's the same compound as that. Or if the RF value is, that looks about half, so 0.5, we will know that on a different filter paper with the same colour, it will be the same coloured spot. Okay, I hope that's helpful.